So welcome back to our UVA series. So in this video, I'm going to demonstrate how to solve this problem in UVA. So it's again in our fourth round select. Problem C, UVA 10327, flip sort. So here's the problem statement. Sorting in computer science is an important part. Almost every problem can be solved efficiently if the sorted data are found. There are some excellent sorting algorithm which has already achieved the lower bound n log n, which indicates the quick sort and the merge sort. In this problem, we will also discuss about a new sorting approach. In this approach, only one operation flip is available, and that is you can exchange two adjacent terms. If you think for a while, you can see that it's always possible to sort a set of problem in this way. A set of integer will be given. Now using the above approach, we want to sort the numbers in ascending order, so you have to find out the minimum number of flips required, such as sort 1, 2, 3. We need no flip operations. Whether to sort 2, 3, 1, we need at least two flip operations. So the input will start with positive integer n, where n is less than or equals to 1000. In the next few lines, there will be n integer, so input will be terminated by n of var. So two lines form a pair again. So 3, then the next line should have 3 elements or 3 numbers. So for each data set, print minimum exchange operations, m prime, where m is the minimum flip operations required to perform sorting. So use a separate line for each case. So if you can see this problem clearly, you'll know that in only one operation flip is available, and you can exchange two adjacent terms. This is the key to solve this problem, which translate into bubble sort. So let's see the bubble sort. So Wikipedia shows a very nice demonstration with GFR here. So let's see how they sort. So we compare these two values. If we move the smaller values to the left, so there's no exchange needed here because of a smaller value on the left already. Then now we need to exchange, and we need to exchange again. So we have done doing this. So we do the same thing again, but we don't have to do this because our biggest value is already on the most right hand side, or the max index in our array. So the second loop. Okay, so we have the two biggest value on the right now, and so on. So by knowing this, we can start doing the questions already. So for this question, buffer reader is not working. I have no idea why, because it's in the UVA system. So in fact, I used some time to solve it, and in the end, I got the answer correct in the first place, but buffer reader doesn't work. I have no idea why. So for this question, we are using scanner. The good thing about scanner is we don't have to care about the exception, but the bad thing about it is slower. So first, test case or until the end. So this while has next line. If it has no line, which means your fn of far, then it will break this while loop. So this is the number of elements we have in our list. So I have a habit of passing the whole line instead of using next integer, because sometimes it will give some um, weird bug if you are the newbie in using the scanner. So try avoid using dot next integer or so on. So if you want to use, then you just use the next line, then you proceed to use string tokenizer or so and so on to get the value. So it should be better in this way. So as you can see, I'm using string tokenizer to get in individual numbers. So now we are loading the numbers into our numbers array. For each tokenized string, we need to connect to integer and so on. So now our number is in the array. Next, we need to put a count. Then we proceed. This is the and so it should be like this, because it should be n minus 1, because we are checking the number in pairs. So when we reach n minus 2, then I will check it against n minus 2 and n minus 1. So it should be 0 and 1, n minus 2 and n minus 1. So then we end here. So we don't have to check it until here, because it will give out the exception. Because we are checking the array out, it will cause the array out bound exception, because we are checking the size is smaller than the array. Not this, we cannot do this. If numbers I true more than plus 1. If the left number is more than the right number, then we need to flip them. So I will use an integer, just temporary value for me to store it. So this will perform an exchange operations. Plus 1 equals to 10. So we have successfully flipped the number once. So we add the counter. So this is the first loop. Then we need to do other loops. So the number of loops required for us to do is n. So it should be n minus 1 instead of n, because let's say I have, so each loop I will get the max value arranged. So this is n, and for the last we don't have to care, so we can reduce one loop because it's pointless, because it's already the smallest. So now we have done, then we can do the optimization here because we already know that the biggest value is on the last part. So don't have to check against the value that we have sorted on the right side. So it should be I here. So the first loop we will check all, the second loop we will check only here, and the third loop we only check here because here is already the largest number that we have sorted. So we can proceed to print out the value. Minimum exchange operations. How? So the question is solved using the bubble sort, but what we need to do is just we add a counter here. So that's it for this question. So if you have any problem, please comment. If you think this video helps you, then please subscribe. There are more videos to come in our UVA series.